What is up everyone, my name is Abhas, your ProtoPie expert, and let me introduce you to Practice with ProtoPie. Here we're going to do a process breakdown of some of the prototypes that you really want to make, and so we'll do a deep dive of all the features that are being used, and you can take that learning and apply it to your own prototypes. Today we're going to learn how to do this very interesting 3D animation effect. You might have seen this effect on the Apple TV icons, but it can be very well done in ProtoPie as well. So let's get started. To begin, let me show you how the layers are set up, and then we can move on to the interactions. You'll notice that there's a bunch of different layers here already. The first one here you notice is, let's say, shadow gradient, and all it's doing is a fill layer. Then you have the oval group, which is basically housing the small gear image and the big gear image. And then it itself has a fill applied, and it also has a radius of 100. And I'll explain as we go forward why this was necessary. Then the next layer we see is the group that's called light, and all it's doing is housing the light gradient image. You can't see it right now because we've enabled the clipping mask. So let me go ahead and disable it here. And so you can see the light layer here now. And then here, this is one of the most important layers here. This is the trigger layer. You can't see it right now, but all the interactions happen to this, and that's what's controlling the entire 3D animation. So to make it visible, we'll change the fill from 0 to 50. And you'll notice that we set the fill to 0 and not the opacity. That's because if you change the opacity of a layer to 0, it will just become not interactable anymore. It will just become invisible to all interactions as well. So just to make it transparent, keep it opaque, but change the fill to transparent. That way you can still interact with that layer. And then finally, the real cool thing here is we have all of these layers inside a group called vertical, but then we've made another group called horizontal, and that's just holding the vertical group. And I'll explain why we did this as well. Now let's get started with the interactions. First off, I'm going to go ahead and disable all the interactions, and I'm going to enable them one by one as we talk about them. So I'm just going to disable them here, and then select them again and disable them here. And now the only interaction that we have enabled is the drag interaction with the move response here. Let's see what this is doing. So what it's doing is it's just allowing you to drag the trigger layer. The drag trigger comes into effect as soon as you start dragging on any specified layer. Here we've specified drag on the layer called trigger. So as soon as there's a drag detected on this layer, it's going to launch whatever triggers you've applied to it. Here we've applied the move trigger. These are mostly the default values for move. There's no restriction whatsoever, no horizontal, no vertical, just a freeform move, a ratio to 100, no limits, and it's applied to the same trigger layer. So that's enabling you to drag this and move it at the same time. Let's go ahead and reset it. Now the first thing that we might want to do here is as soon as you stop dragging and do the touch up, you just leave the layer, you want to make it move back to its original point. Now to make that happen, we have to do a touch up trigger. The touch up trigger comes into effect as soon as you stop touching a layer. Here we specified the trigger layer. So as soon as you touch up on the trigger layer, all of these responses are going to come into play. Now for the first response, we just want to move the trigger layer back to the center. And that's what we're doing. We're saying move it to 0, 0. And let me just enable this. And let's see what's happening here. So as you can see, whenever I do a touch up, now it's moving to 0, 0. Now you might wonder, well, 0, 0 is usually this kind of corner here. So the reason it's moving here and not there is because it's inside the vertical group, and the vertical group itself has these boundaries, so it's moving to the top left corner of this here. Alright, now the second thing that we want to do is we want to detect the range of motion that the trigger layer is going through. So to start, let's do a detect on the x-axis. Detect as a trigger will check for any changes for any of the values that you specify. Here we've chosen the trigger layer, so any changes to the trigger layer, but what aspect? Well, we want to check only the changes to the x-axis. So if there's a motion on the x-axis for the trigger layer, then this trigger is going to come into play. So now that we know that all of these responses can come into play whenever there is a change on the x value of the trigger layer. To start, let's check out the first response. It's the assign response, and again, this one is going to be very important in the prototype. What we're doing is, let me turn this guy on, is as soon as there is motion on the x-axis by the trigger layer, assign as a response, you want to assign a particular value to a variable. So we have two variables on this file. The first one is called velocityX and the second one is velocityY. We'll get to that. But for now, velocityX, we're saying assign something to velocityX. Assign what? Well, you can assign any kind of number or you can assign a kind of formula. You can assign, even sometimes you can assign a character as well. But for now, we're assigning a formula. And this formula is baked into ProtoPie. All the formulas that begin with a $sign usually are baked into ProtoPie. So what it's doing is, it's called touchVelocityX, and what it's doing is it's the velocity of movement along the x-axis. So whatever that value is, assign that to this variable we've called velocityX. And we're going to do the same thing on the y-axis. So in this kind of pair, we have another detect trigger, and it's, instead of being programmed to the x-axis, this time it's programmed to the y-axis. And here we're going to do the same kind of thing. We're saying assign to this variable velocityY. Let me turn this guy on. And what do you want to assign? You want to assign the same formula, but this time only get the y value. Now let me show you something really interesting. To view the value that is being assigned to any variable, go ahead and hover on this variable layer here and press the debug icon. It's going to make it visible inside of your scene. Let me make the other one visible as well. So now you can see, and you can move these guys around by the way. So now you can see the velocityX variable and the velocityY variable. And they're both set to 0 because that's the default value that's been applied to the variable. Now let's do a preview. So we're saying every time there's movement on the x or y axis, then assign it to the velocityX and the velocityY variable. So as you can see, if I just move on the x-axis, it's mostly just changing. You can see that it's just changing. I'm trying my best here not to move along the y-axis, but if I'm moving along on the x-axis, it's applying that to the velocityX variable. And the same thing if I move along the y-axis, it's just making that application to the velocityY variable. Now the interesting thing to note here, and again very important, is as you move towards the right, you get a positive velocity for the x value. And if you move towards the left, you get a negative value. Similarly, if you move downwards on the y-axis, you get a positive y value, but if you move upwards, you get a negative y value. And these are important so that you know which direction you're moving in. And this is why you have to use the touch velocity variable. It's going to help you tell the direction. And this is why knowing the direction is important, because we're going to be applying a 3D rotate response here. Now the way that 3D rotate works is you want to rotate by a particular value. So we specified a formula here. Let me go ahead and remove that for a second to show you. But you can specify any angle that you want to rotate by. You could also use a rotate to a specific amount, and it's the same kind of thing as when you do in move as well. Now the second thing that you can specify is the direction. The direction of movement is along the y-axis here, and you're saying move along the y-axis towards the right. The other directions you get are horizontal, up or down, or along the y-axis, left or right. So you want to move it towards the right along the y-axis, and you're applying this effect to the vertical group. Now what this does is, let's take a look at this. Now you'll see here that whenever there's a movement along the x-axis, there's a 3D rotate with the y pivot here, as you can see. And the way that this direction is being deduced is because we've used a formula here. Now what exactly is this formula? You remember the variable that we had, velocityX. we're multiplying that by 0.001, which is essentially you're dividing by 1,000. Now why are we doing that? So let's take a look at the velocityX value that we're getting here. And you can see it's a very large value. It's 50 or sometimes even 100. And if I'm moving too fast, it's like 200, 300, so on and so forth. And what we're doing is we want the movement to be very granular. We don't want it to move one-to-one with whatever is specified in the velocityX variable, because that's going to be very high an angle to 3D rotate along. So let me show you what's going to happen if you don't have this kind of granular multiplication here. So I'm going to remove this part, press enter to save it, and let's say preview now. So now it's going to move one-to-one with whatever value of velocityX we have. So let's see, it's just out of the world. But if I move it slowly, look at that. The movement is like, it's too high, right? So we want to divide that by 1,000. That's why we're multiplying by this amount. Press enter and save it, and let's see. There you go. Now it's a much smoother effect. We're going to do the same thing, we're going to do the same kind of 3D rotate, but now along the y-axis. So let me turn this guy on. Now here you'll notice that this response has been applied to the horizontal group and not the same vertical group. And this is the reason why we had two of those groups, essentially covering the same area and the same layers. The reason is sometimes when you apply some effects to a specific layer, especially effects like move or translatory kind of motion, to the same layer, to the same group, it's going to create a conflict. It's going to create a confusion within the ProtoPie application whether you want to move it along the y-axis or the x-axis, and it just gets very confusing. You can't simultaneously do it without causing some kind of conflict. So let's see what that conflict also looks like. If I had applied this to one particular group called vertical, now let's see what this conflict is going to look like. So you see, it's not working right, and it's just glitching out. So in order to resolve this conflict, we've separated these two layers. One is just going to deal with horizontal motion, and one just going to deal with the vertical motion. And that's why the rotation along the horizontal axis is taken by the horizontal group, even though it has the same layers, and the rotation along the y-axis is taken by the vertical group. So let's see here. And now you can see even on the y-axis, the 3D rotation is happening. So but the bulk of the effect starts to appear in place now. Now, before I go forward, let me clarify again here that you're using the velocityY variable, but you're multiplying it by 0.001, or you're dividing it by 1,000, because if you move one-to-one, it's just going to be very kind of glitchy. The motion is not going to be very smooth. So in order to make it a bit more granular, that's why you kind of reduce that value. Now, let's look at all the move responses that we've applied. And move is one of those core responses that we should know about. So what we're doing here is we're moving the small gear whenever there's changes on the x-axis, right? So what is this movement happening by? Now again, move can happen by or to. We don't want to move to a specific location. We want to move by a certain amount, so we've chosen move by. The easing is set to linear instead of the usual ease in and out. The reason is we want there to be a very linear motion. We don't want any kind of easing to happen here. In fact, you'll notice that even the duration is set to 0. We don't want this. It needs to happen instantaneously as you're dragging, and hence these values. Now the important thing here is we need to specify a formula here instead of just a numerical value. And again, the formula, the amount we're saving in this variable velocity x, the movement along the x-axis, we're multiplying that by negative 0.0009, and essentially that's just 9 divided by 10,000. Again, the reason for this is we need to make it granular. Now if this was less granular, let's say if I were to make it 0.1, let's see what happens. So you'll notice the small gear is moving by a lot. We want the movement to be tiny, very smooth, very granular, and that's why we're going to change this back. Oops. Back to 0.009. 0.0009. All right, and we're doing the same thing along the y-axis. We're saying velocity y times negative 0.0009. Now, one more thing to note here is we're using a negative symbol, and that might seem strange. Well, why are we doing that? The reason is we want to move the gear in the opposite direction of our drag. So if we are dragging towards the right, we get a positive velocity x value, but the gear needs to move towards the left. So that's why this is being multiplied by a negative symbol so that the value of motion is reversed. Okay, so we're going to do the same thing again here. We're going to move the small gear layer, but this time it's under the detect Y trigger. It's the same formula as before, and we're going to turn this trigger on, and let's see what this does. So now you can see that when I'm making changes on the y-axis, the gear is still moving, and if I'm making changes on the x-axis, the gear is still moving. And the value of motion is multiplied by a negative sign, so if I'm moving upwards, the gear moves downwards, and if I'm moving towards the right, the gear moves towards the left. All right, so far so good. Now, the same thing is essentially happening to the big gear layer. It's the same formula, but a slightly different kind of granularity. So if that one was being moved by 0.009, which is higher than 0.005, which is even lower, because we want to move this one slightly lesser. We want to create that effect of parallax. And we're going to use these same values on the y-axis as well. So we're saying multiply velocity y by a negative of 0.0005. And so let's see what this does. And I'm going to go ahead and turn this guy on for the Y trigger as well. So let's see. Now you can see the big gear layer and the small gear layer, they're both moving in response to my movement of the trigger layer. Great. I'm going to go ahead and reset this guy. And let's come back here. Now one more thing that we're moving is the actual group, the group oval. Now we're moving this again by the same kind of formula, but we've reduced that a little bit lower as well. So the first one was velocity x times minus 0.0009, then we had 0.005, and now this one is 0.0003. And the reason for that is this one needs to move even lesser. So we're doing the same thing along the y axis as well. We're saying multiply velocity y times minus 0.0003. And we're going to do the same thing here, but for detecting on the y axis. So let me turn this guy on, and let me turn this guy on, and this should move the oval layer. So let's see now. Now you can see there's a movement in the oval layer as well. All right. Now we're doing one more thing, which is moving the light gradient, which is how you get that shiny effect. So we're saying move the light layer, but no changes on the y-axis, only change along the x-axis, and you're multiplying velocity x, which is the same number we had as before, velocity x, times negative 0.25, which is a lot of movement, and the movement direction is reversed because you've multiplied by a negative sign, and you're moving the light layer. So let me turn this on, both for the detect on x-axis and detect on y-axis, and let's see what's happening. So now you can see, because the movement is specified only along the x-axis, it moves only in a horizontal direction. Whether you're dragging it up or down, the movement for the movement for the gradient, light gradient layer is only happening along the x-axis. Okay, now it seems like most of the things are in place. Let me point out one more really cool thing here is the oval layer is actually, just a group as I specified before, and the radius, you might remember, is set to 100. So what's happening is, as I move, you see that the images, the gear images inside, they don't go outside this group at all. That's because we've enabled a clip sublayers toggle here. So if I were to remove that, you're going to start to see the gears move outside. You can see that the gears are now moving outside of the oval group. So in order for this effect to work, and this kind of circular thing looks like a hole, we don't want the stuff to be visible outside of it. So that's why we specify clip sublayers. And let me just show you what happens if the radius was not set to 100, if it was set to 0, which is the default value for all containers and groups. You can start to see that it's no longer an oval, but the clipping works, so you can see that the effect is still is in place. All right, let me reset that. Let me go ahead and change the radius for the oval group back to 100. You can even specify a different kind of radius for different corners, so you can just have a 0 for one corner, and this is cool for some interesting effects as well if you want to do like a teardrop shape. So yeah, this effect can also come in handy, but for now, let's just go ahead and change it all back to 100 so that it looks perfectly circular. All right, now you might remember we're moving this red trigger layer back to the center when we do a touch up. So we want to reset everything to its default value when we do a touch up, and which is why we have all of these responses. So let me explain how these are working. So as soon as a touch up happens on the trigger layer, you can even specify how many fingers you're doing a touch up with, because you could have a separate response if you were to do a touch up with 2 fingers. But for now, we just want to do 1 finger here. So when you do a touch up with 1 finger, move the red trigger layer back to the center. That's why we specified move to, not move by like before, move to 0, 0. Again, the easing, we just wanted to feel very natural, so the easing is set to linear and the duration is very small. It has to happen very quickly, so the duration is 0.1. Now for the other things, let's say the small gear, let me turn this on. We're saying move to 65, 65. And the way to get these values is you click on the small gear layer in its default position, and you see that its default value is set to 65, 65. And that's what we've used here, which is the default value. Now a cool way to get the default value in ProtoPie is you can just see that the default value is kind of visible to you. So you just need to type that out and you can have that here. So now if I were to do a touch up, the small gear should move back into place. It's looking a little wonky right now because all of the other layers are not moving back into place. So let me do that as well. So we're going to do the same thing for the big gear layer. We have a move response here and we're moving back to 65, 65. And the reason that these guys all have the same origin, which is 65, 65, is because both the small gear layer and the big gear layer have their origin set to the center. And that's, again, very important when you're doing a 3D rotate. I'll explain to you why as we go forward. Now, let's see here. We have, again, we want to move the oval group back to its original value, which is 150, 90. Let's look at that right here. It's 150, 90. So all we're doing is we're just moving it back to its original place. And we're moving the light gradient back to its original place again, which is 976. We're not specifying any y value here because we're not moving this layer along the y-axis at all. So let me turn this one on as well, and you can see now the things are moving back to their original place, but the 3D rotate isn't snapping back. So let's reverse the 3D rotate as well. So you'll notice we're doing 2 kinds of 3D rotate here. One is along the x-axis and one is along the y-axis. The one along the x-axis is here. We're doing this kind of 3D rotate here, and along the y-axis is right here. And here all we're doing is reversing both of them. But we've done it 4 different times, and we've separated each of them using conditions. Now the way to use a condition is every time you have responses underneath it, those are the only responses that are going to come into play if the condition is true. And you can specify the condition using these preferences here. Now the first check we're doing here is the velocityX variable. Is it less than a particular value? and that value is 0. So that means if velocity x is less than 0, which means it's a negative value, which means the motion is happening towards the left along the x-axis, then this condition is met. We've specified another condition here, and you can add many more conditions here by pressing the plus button. Second condition is the velocity of y should be greater than or equal to a value which is 0, which means the y direction should be downwards. So if your velocity of motion was towards the left and downwards, then we want to do a 3D rotate but in the opposite direction. And that's why it's important to know which direction you're moving in. And that's why it was important to use the touch velocity variable. Alright, so what we're doing here is we're just reversing the direction of 3D rotate here, as you can see. And the first response is we're reversing the direction of the vertical layer and rotate it back to 0. No matter what angle it was, change it back to 0. The direction should be opposite. So if you were moving towards the left, now rotate along towards the right. And if you were moving downwards, then rotate upwards and again to 0, and this time this is happening on the horizontal group. Now one more thing to notice here is whenever you do a 3D rotate, you'll notice that there is a pivot, and this pivot can be changed to origin or it can be custom. We've kept origin because we want to rotate the layer along the central axis, and the way to make that happen is whenever you select any layer, the origin must be set to center. If this was not the case and if you had left it to the default value, let's see how the rotation happens now. Now you'll notice the rotation is a bit wonky, but it's happening because the horizontal rotation is happening along this as a pivot. If you move it to center, now the rotation will happen along the center. Okay, now let's get back to our conditions. Now we're doing the same kind of 3D rotate, but for different directions. So the second set of conditions is if the x direction is positive, which means you're moving towards the right, and for the y, it's a negative. So if you're moving upwards, so if you're moving right and upwards, then rotate to the left and rotate downwards. And let me enable these guys. And again, we have another condition set. What we're saying here is, well, if the velocity x is greater than 0, so you're moving right, and the velocity of y is also positive, and you're moving down. So if you're moving right and down, then rotate towards the left and up. And let's go ahead and enable these guys. And again, for these condition sets, and for this condition set, we're saying if your velocity x is less than 0 or negative, which means you're moving towards the left, and y is also set to less than 0, which means you're moving upwards, so left or upwards, then rotate towards the right and rotate downwards. So let me turn these guys back on, and now everything should be falling into place. There you go. Now it's all moving whenever I do a touch up, but just to make the effect look really convincing, we're going to enable a few clipping masks. What we're going to do is we're going to select the vertical group and say clip sublayers. Now you can only see the gradient as it passes over this layer, otherwise it's not going to be visible. And the second change is we're going to change this guy to be invisible again. And the way to do that is you set the fill to 0, not the opacity, because if you change the opacity, then you can't even interact with it. In fact, let me show you how that works. So now you can see that it's all moving as we intended. Perfect. But let me now change the opacity of trigger to 0. And let's see what this does. And now you can see it won't even come into, it won't even be detected by the interactions. Alright, so let's go back and change the opacity. You just need the fill to be transparent, not the layer. Alright, and let's take a look, and here we are, we're done. That was easy as pie, wasn't it? Now before we go, I'd also like to make a special shout out to Junhyuk Jang, who made this awesome prototype. I've made a few changes here and there to make it easier to explain, but essentially it's the same thing. Now I hope this feature breakdown was helpful to you. If there's any other prototypes that you'd like us to break down, or any other features that you want to learn about, please drop us a response on the link below. Until next time then!